Science. This is Mr. B, and we are going to wrap up the first section of Chapter 15 today, talking a little bit more specifically about energy. So remember, we have our two main big groups, our kinetic and potential energy. And if we kind of break it down even a little bit below that, we're going to have other different forms of energy that can be classified as different types of kinetic and different types of potential energy. So we have some different major forms of energy. Now don't get confused about these, because all these still have to deal with potential and kinetic energy, but there's mechanical, thermal, chemical, electrical, electromagnetic, and nuclear energy. Again, those are all different forms that can be classified underneath kinetic and potential in some way. So all energy can be considered in one of three forms: kinetic, which we already said, potential, and then there's energy in fields, such as those produced by electromagnetic waves, which we'll talk about that a little bit later on. And each of these forms of energy can be converted into other forms of energy. So energy is constantly being converted between, again, these forms right here and these forms up here in everyday life all the time. And we're going to focus on that more in our next section of this chapter about how this energy conversion actually goes on. So our first form of energy is mechanical energy. And this is energy associated with the motion and position of everyday objects, and that's mechanical energy. And if you notice, motion has to deal with kinetic energy, and position, remember we talked about gravitational potential energy, about how high up it was. That is associated with its position. And if you look down here, mechanical energy is the sum of the object's potential and kinetic energy. So if you just look right up here, its definition, if you remember what kinetic and potential energy actually mean, then it's pretty easy to see that mechanical energy will be the sum of those two. So that's our first kind of new form, is mechanical. And then there's thermal energy, and so the total potential and kinetic energy of all the microscopic particles in an object make up its thermal energy. And this, we've kind of hit on thermal energy before when we talked about pressure, because when an object's atoms move faster, its thermal energy increases and the object becomes warmer. So we talked about earlier on in the year, particles increase their speed as they become faster. There's more collisions, so therefore heat is going to be greater, and there's going to be a greater pressure. That kind of has to deal with thermal energy, again, because it deals with microscopic particles and how fast they're moving. So again, I guess the example that we went over earlier in the year is that the tire, when it is driven across the road, again, that friction between the tire and the road is going to generate heat. That heat is going to make particles move faster, therefore it's going to cause the pressure in the tire to increase, and so now we can kind of even add more to that and say it's going to increase the thermal energy of those microscopic particles within that are within the tire. So that's our second form, is thermal energy, and they give an example here. Hopefully this is kind of common sense here, but the molten metal is extremely hot because it contains a great deal of thermal energy. So a lot of thermal energy inside this molten metal. Again, the particles have a great deal of potential and kinetic energy as the temperature increases. So that's our second form. So we've had mechanical and thermal. So now we have chemical energy, and this is energy that's stored in chemical bonds. Again, we talked about chemical bonds briefly before the end of the first semester. And when bonds are broken, the released energy can do work. All chemical compounds, including fuels such as coal and gasoline, store energy. So our cars are powered by fossil fuels and other things like that. So other things are powered by fossil fuels as well. So that's chemical energy kind of being released when we are driving our cars every day, or when you are, I don't know, if you are an old train conductor and you're scooping the coal into your engine to power that, that is, again, releasing chemical energy that is stored in the bonds of those fossil fuels. And another one, this family is using chemical energy of burning wood. So wood, again, a chemical change when you light it on fire, is releasing chemical energy to produce thermal energy for heating marshmallows. So the chemical energy from the burning wood is released, and it is transferred or converted to produce thermal energy for heating up marshmallows. So that's kind of a simple example of how energy can be transferred, or can be converted into a different type. So again, so far we've had chemical, thermal, mechanical. Our next one, electrical energy, and this is just energy associated with electric charges. So again, like protons and neutrons have electric charges, or I'm sorry, protons and electrons have electric charges associated with one another. So electric charges can exert forces that do work. So whether you're attracting or repelling something, again, that can be a form of electrical energy. So our next type is electromagnetic energy, and this is a form of energy that travels through space in the form of waves. So visible light and X-rays are example of electromagnetic energy. I don't know if we're going to have time to make it to waves, but I think hopefully you've maybe learned that light and sound are actually made up of waves. Again, I don't know if we're going to have time to dive much into that later on because we're going to start to run out of time here before the end of the year. But again, that's all a form of electromagnetic energy. Again, light and X-rays being an example. I think we're going to have, again, another example here that lightning bolts will transfer an electric charge. Again, right here. And galaxies are giant structures in space that typically contain billions of stars. The stars give off enormous amounts of electromagnetic energy, and they're constantly exuding different rays. And again, that kind of makes sense if you know, because the stars giving off electromagnetic energy, visible light, a lot of our visible light comes from the sun. The sun is a star, so it's giving off a lot more electromagnetic energy there. And then I believe our last one here is nuclear energy. So the nucleus, remember we've talked about how nuclear and nucleus are associated with one another, of an atom is held together by strong and weak nuclear forces, which can store an enormous amount of potential energy. So remember, we talked about in theory, and the nucleus of an atom should not want to stay together. It should be repelled apart because there's a bunch of positive charges in there, but there's the strong nuclear force that is holding it together. And so that strong nuclear force has a great amount of potential energy, and this energy stored in the atomic nuclei is known as a nuclear energy. So the energy that's stored in the nucleus of an atom is known as nuclear energy. And there's a process of nuclear fission that releases energy by splitting these nuclei apart. So a lot of the nuclear power plants, that's what they do around here. They split the nuclei apart, and that releases the energy that's stored within the nucleus. And there's another process called nuclear fusion. So the difference between fission and fusion will probably be around somewhere on a test here. So fission releases the energy by splitting the nuclei apart, and fusion is going to release energy when less massive nuclei combine to form a more massive nucleus. So when you actually push the atoms together to form a bigger nucleus, that is going to generate a lot more energy, and this is actually the process that goes on inside the sun. So we have not been able, for what I know, to really harness this process on Earth too efficiently. If we did, it'd probably be a much more efficient energy source for us rather than splitting the nuclei apart. Pushing them together would probably be a more beneficial way to do it. So that's it for our different types of energies. Again, nuclear, electromagnetic, electric, chemical, thermal, mechanical, and then that's it. And again, hopefully you can kind of see how we've hit on all of these at some point in time throughout this year. So that's it for this video. Let me know if you have any questions.